Okay, using calculus to analyze graphs. So you're not really using a calculator at this point, you're just using your calculus. So when they say find the minimum and maximum values of this function on the interval, you're going to use the sign chart. So let's set up the sign chart first. I set it up by finding the critical values. So let's take the first derivative, and I get 2x minus 2, set that equal to 0, and I get 2x equals 2, so x must be 1. So my critical value equals 1. Now, because they have an interval, when you do your sign chart, you're going to put the 0 and the 3 on that interval, and you're going to put your 1 like you would normally. So now let's analyze it. We're just going to use the first derivative test. Okay, if you plug in between 0 and 1, let's pick 0.5. If you plug in a 0.5 or a 1/2 into this equation, do you get a positive or a negative? Well, let's see. 2 times 1/2 gives me 1. 1 minus 2 is negative. Therefore, right here, my function's slope will be negative. Therefore, my function is going in this direction. Then let's plug in a number in this interval. So let's pick 2. So plug in a 2. 2 times 2 is 4. 4 minus 2 is 2, which is positive. So that means my function's going this way. So what I have found, so the CV of 1, looking at just that, I see that 1 is a max, is a min, it's in my head, since the slope changes from negative to positive. Okay, so now we have a complete sign chart. So I know I have a minimum there. Now, I'm only allowed to look in this interval. So now you need a maximum value and a minimum value. So what I'm going to do is I'm going to come over here and I'm going to evaluate the function at 0, and I get a value of 1 plugging in. I'm going to evaluate the function at 1, and I should get my lowest value. So plugging in a 1, I get 1 minus 2, so that's negative 1 plus 1 is 0. And again, I'm plugging it back in the original function. And if I use a 3, 3 squared is 9 minus 6, that makes it 3, plus 1 is 4. All right, so now I'm able to make a statement. Where my function has an x value of 1, it has a minimum value of 0. So this is my minimum value right here. 0 is my minimum. Given the interval, what is my maximum? 4 is my maximum. And that's how I would handle that question and the answer. So what makes this different about a regular sign chart is that I am capping my interval at 0 to 3. And then even though I found a minimum, they're asking me to still find a max, and I evaluate each of my endpoints to do that. Okay, let's go on to question number 28. Okay, this question asks us to find the open interval, so I don't have a closed interval like I did in the previous problem, on which this function is increasing or decreasing. Again, the best approach is to use a sign chart. So set up your sign chart by first finding the critical number or the critical value by setting your first derivative, which is going to be 3x squared minus 6x equal to 0. Okay, so factor that, and we can factor out a 3x, and then we have x minus 2. Just check. Yep, that works out. So my critical values, setting each factor to 0. This factor gives me an x of 0. This factor gives me an x of 2. So set up your sign chart, go from left to right, and I'm going to evaluate my sine chart to the left of 0. So I'm looking at f prime of x. I'm looking at f of x down here. So looking at a -1 value, if I plug in -1 in the first factor, I get a negative. -1 minus 2 is also a negative. A negative times a negative is a positive. My function is heading up. Plug in a 1 because that's a number in this interval. 3 times 1 is 3. 1 minus 2 is a -1. A positive times a negative gives me a negative. Therefore, my function is downward sloping at that point. Pick a number to the left of 2. So let's pick 3. Plugging 3 in gives me 9 times 3 minus 2 is 1. That'll be a positive. Therefore, my function is upward sloping. So I need to figure out where my function is increasing or decreasing, so I can see from looking at my sine chart that my function is increasing from -infinity to 0. Then I see my function is decreasing in this window right here. So it is decreasing from 0 to 2, and then my function is going to go back to increasing in this window. So it's increasing again from 2 to infinity. And that's how I can use a sine chart to analyze where my function is increasing and decreasing without ever having to graph it. Okay, let's go on to question 29. Okay, in question 29, similarly to question 28, they're asking us to analyze this function and figure out where it's increasing or decreasing on an open interval. So they're not giving us limitations. So again, the sine chart is your friend. Take the first derivative of your function. You get 2x minus 2. Set that equal to 0 to find your critical value. 2x equals 2. X equals 1 is your critical value. Set up your sine chart. Remember, the top is your slope. The bottom is the direction of your function. Your critical value is 1. Okay, pick a number. Okay, here is my first derivative. So what I should do, let's factor that because it'll look nicer to deal with. So I'm going to put that over here because I like to evaluate it when I have a factored form. So that's going to be 2x minus 1. All right, so if I plug in a 0, because that's to the left of 1, 2 times -1 gives me a negative, and that means the function is decreasing over that interval. If I plug in a number in this area, so let's pick a 2, 2 times 2 minus 1 is 2 times 1, which is positive, so therefore my function is increasing. So now we can answer the question. My function is increasing, or maybe we'll do decreasing first. So let me back up. My function is decreasing from -infinity to the critical value of 1. Then my function is increasing from 1 to infinity. So these sine charts come in very handy. They're quick and easy. And there you go. All done. Let's do problem number 30. All right, in this question, number 30, they ask us to find the relative extrema for this function. So again, sine chart is in order, and I start out by taking the first derivative, and I get 3 times 2 is 6, x squared plus 6x minus 12. Okay, so I'm going to factor that, but first I'm going to use my greatest common factoring and take out a 6. So now I have x squared plus x minus 2, and that's an easy factoring problem. So that's going to be x plus 2, x minus 1. Just checking, yep, that works out. So I can identify my critical values as -2 and +1. Okay, so be careful. Make sure you do these easy steps correctly because everything else is based upon it. So I said I had, let me just erase this guy. I had a -2, so that's going to come first, and a +1. So the top is always your slope, the bottom is always your function. Let's evaluate this. The relative extrema is where the slope is 0. That's why I have used my critical values. So if I pick a number to the left of -2, so let's pick like a -3, and what I see is if I plug a -3 in, so I'm going to have, this will be negative, this will be negative, negative times negative is a positive, my function will have a positive slope there, and that means my function will be increasing. Then pick a number in this interval, and I'm going to pick a 0. So I'm going to have a 2 times a -1, that'll be negative, and therefore my function is decreasing. Now let's pick a number to the right of 1, so let's pick 2, and that's going to be a positive times a positive is a positive, so my function is increasing. So I know that at the critical value of -2, I have a max because my slope went from positive to negative. Okay, at the critical value of 1, I have a min because my slope went from negative to positive. Okay, so now let's get the y values. So I know I have a max where I have an x value of -2. Plug your -2 back into the original equation. And doing that math, you should get a 20 for your y. That is my max, and it's a relative max. So it's an extremum. So my minimum value happens where x is 1. If I plug a 1 back into the equation, I should get a -7 for my y value. And those are the coordinate pairs which represent the relative extrema. So it's not absolute max and mins, they're relatives, and I give it as x and y's. Let's go on to question 31. Okay, question 31 says use the first derivative test to find the x values at a relative extrema for the function at hand. So the first step is always to take your derivative. So I'm taking my derivative, and I get, careful here, -4 x cubed plus 6x squared. So I'm going to factor that. I'm going to take out a -2x squared that they have in common. And I need a -4 back, so it's going to be 2x minus, so careful here, and that's just going to be 3. Okay, those are my factors. Go ahead and set your factors equal to 0. This first one gives me a critical value of 0. This second one gives me a critical value of +3/2. So on my first derivative test, I'm going to start out with my sign chart, and I'm going to have the critical values of 0 and 3/2 noted. And then the top is your slope, the bottom is your function direction. Using the factors above, if I plug in a -1, I should get, let's see, this will be a negative, this will be a negative, so a negative times a negative is a positive. My function's going that way. Now plug in a critical value, plug in a testing value of 1, because that's on that second interval. That'll be a negative times a negative. That will also be a positive. Okay, this is the first time that we've had this happen to us. Then check a number to the right of 3/2, so let's pick 2, and that will be a negative times a positive, which is a negative. Okay, so where my function is positive, it's still going up. Where my slope, is positive, my function is going up. Where my slope is negative, my function's going down. So what have I found? Well, I found this relative extrema. The first one is an inflection point because I do not have a sign change in my slope. So I have an inflection point where x equals 0, and then what's happening at 3/2? I am going up and then I'm going down in terms of the direction of my graph. So that means I have a max at x equals 3/2, and they only wanted the x values. So I need to write a statement about my sign chart. So I would say at a critical value of x equals 0, there is no sign change with our slope, so that yields an inflection point. Then I would say at a critical value of x equals 3/2, slope changes from positive to negative, and so therefore, 3 little dots, therefore you have a max. Alright, so here is my answer. They only want the x values. One's an inflection point because there's no sign change, and the other one is a max because the sign of the slope changes from positive to negative. Okay, moving on to question number 32. Okay, question 32 asks us to find all the intervals for which the graph of the function is concave down. So concave down looks like this. So you have a couple of options. I'm going to use a second derivative to check this. So let's get the first derivative. So I have y prime equals 3 times x. 3 times 8 is 24, so 24x squared minus 8x cubed. Okay, so that's our first derivative. Let's go for our second derivative. 2 times 24 is 48x minus 3 times 8 is 24x squared. Okay, I'm going to factor that because I'm going to set that equal to 0 to find my inflection point, which is important because that's where the concavity changes. So let's factor that. They have a 24x in common, so I need a 2 to get back a 48x, minus, I just need an x, so I have 2 inflection points. One is at 0, and one is at 2. Okay, so it means I have 2 places where the concavity is changing. So this time, I want to check the second derivative. Okay, and then I want to know the direction of my function. So this is still going to be the function, but this is going to be the second derivative. Alright, if I check to the left of 0, so if I plug in a -1, so that's going to give me a negative. 2 minus -1, that's going to give me a negative times a positive, which is going to give me a negative. So I have a negative in this interval. If I have a negative, then that means right here my function is concave down. So it's concave down right in there. So it's going to look kind of like that. Okay, from 0 to 2, pick a number. I pick a 1. If I plug in a 1, I get a positive times a positive, which is a positive, which means my function is concave up during that interval. Then let's check to the left of 2. Pull a 3, that's going to give me a positive times a negative, which is going to give me a negative. If it's negative, it's going to be concave down, which looks like that. So they want to know the intervals where they're concave down. So those intervals, let me just erase this little thing. Those intervals will be, I am concave down, from negative infinity up to the inflection point of 0. Then I am concave down again from 2 to infinity. And now you should graph this because you're still learning about this stuff. You should see that you have 2 inflection points, one at 0, one at 2, and you should be able to affirm the fact that it's concave down, and then it changes to concave up, and then back to concave down. They only are asking us where it is concave down, and you need to have it in intervals, and that's your interval notation, and you're all set. Let's go to question 33. Okay, in this question they're asking us to find all points, all points of inflection. So that means I need a coordinate pair, and I'm looking at a cubic, so I know a cubic, usually my concavity changes one time, so I'm probably going to only get 1 point. So now with this in mind, let's go ahead and start our approach to the problem. Take your first derivative, which is going to be 3x squared minus 6x minus 1, and then take your second derivative, because we're talking concavity, which is in the second derivative. So 6x minus 6. Okay, factor that. And I do indeed get one x value where my second derivative equals 0, and that x value is 1. So all they want is the point of inflection. So I know that the x value is 1. Put that 1 in the original equation to get your y value. And when you do that, you should find that your y value is 4. And you are done. And you can check that with your calculator now because you're learning how to do this. So you should see that there's a point of inflection. Remember that an inflection point shows you where the concavity changes, and that should happen at 1, 4. Okay, let's go on to question number 34. In question 34, they ask us to find all points of inflection, and I see I have a quartic, so I'm thinking I'm going to have 2 points of inflection. So let's check that out by taking the first derivative, and the first derivative is going to be 4x cubed minus 3x squared. Take your second derivative, and that should get you 12x squared minus 6x. Factor that because I have to have that equal 0. They have a 6x in common, so I need a 2x minus 1. So therefore I have 2 points of inflection, one at each of these roots. So one point is going to be at 0, and the other point is going to be at 1/2. Okay, so now what I have to do is plug in the 0 in the original function. I get another 0 back, plug in the 1/2 in the original function, and when I plug in the 1/2, I should get negative 1/16 back if I do the math correctly. Alright, those are my 2 points of inflection. And again, you could check this with your graphing calculator, because you want to make these connections so that when you are not using a graphing calculator, you have built some confidence in your analysis skills.